Hey everyone, it's Mr. Gordon, and today I will be helping you factor using dots. So dots stands for difference of two squares. So with that being said, there are four different things that you have to look for in order to be able to use dots. So it's a little different from GCF if you saw the last video. But here we want to make sure that we have two terms. We want to make sure that there are even exponents. You want to make sure that you're using perfect squares. It's difference of two squares. So perfect squares is a must, and you have to make sure that subtraction is being used. So in this example right here, we have two terms, we have subtraction, we have our even exponents, and we'll assume here that A and B are some perfect squares. So anytime we see something like this, your final answer should look a little bit like this. And we'll see some more examples as we go on. In this example below, this is something you might see on an exam or in your classes, on the regions. We would have something like this where there are even exponents, we have two terms, there's subtraction, we see perfect squares, we're good to go. So I like how this example kind of split it up because it looks a little bit like this. Okay, so we have that 7 squared. All we did was take the square root of 49. So you have to be you have to know your perfect squares in order for this to be a little bit easier. So if perfect squares is something that you struggle with, you might want to write a list on the side. That's what I tell my students to do to kind of help you along. Anytime you're doing dots, you're always going to have one plus and one minus, and that's going to be very important for this one as well. So let's just hop right into it. We have something like this. You can very well see this on your Regents exam. I'm keeping my checklist in mind. So I have two terms. I have even exponents, yes. I have perfect squares, that 25 is a perfect square. And then I also have subtraction. We can do dots. So here, I want to always open up two sets of parentheses. So one here, and then I'm just going to copy this over. Then I have another one. You always want to make sure, like I just said in this example, that there is a plus and a minus. So I'm going to put a plus and minus in here in my parentheses. We're good to go. Now, I always tell my students, what letter are we working with or what variable are we working with? Obviously, it would be the x. So I'm just going to put an x here and here. And then for this 25, you always want to take the square root. Basically, what we're doing is taking the square root of each thing, of each term. So actually, let me do this, and I'll put this in blue. Taking the square root here. Square root of 25 will be 5. So this right here will be your final answer. Pretty simple. Let's go on to the next one. We see something like this. Now, in this example, we didn't have a coefficient here, but we know that that invisible coefficient would be a 1, and 1 is a perfect square. Here, we see a 16 and a 1. Both of these are perfect squares. We can check off the rest of our checklist. We have two terms. We have subtraction. We have an even exponent. We're good to go. So here, again, I'm going to open up two sets of parentheses. All right, we have two sets of parentheses. Our signs in the middle, we're always going to put a plus and a minus. And if you're wondering, it doesn't matter. I could put the plus over here and the minus over here, and it'll be the same thing. I'm actually going to leave it like this for right now. And then remember, all we're doing is taking the square root of each term. So I'm going to do 1 first because this is simple. 1 times 1 is 1. So the square root of 1 is 1. So I'll put that here. And then here, anytime we're taking this square root of something that looks like this, I want to deal with my numbers first, and then I'm going to deal with my variables. So here, the square root of 16 is going to be 4. So I'm going to put a 4 here. I'm going to put a 4 here. Then x squared, anytime you're taking the square root of a variable with an exponent, you're always going to divide. Let me write that. Divide the exponent by 2. Always dividing the exponent by 2. I always say we're kind of splitting it in half. So if I'm splitting this, it's going to be an x right here and an x right here. And boom, this is it. And let me box my answer. We're good to go. Our next example over here, very similar to what we just did. I'm going to open up my parentheses. We should already be knowing what signs go in the middle. So I'm going to put a plus here, minus here. Again, the order of the plus and minus doesn't matter. We can switch it. I'm going to take the square root of both sides. Again, let's do this red one first. I'm going to do my numbers first, which is going to be a 2. The square root of 4 is 2. And again, we're just splitting the x's. And remember this note over here, we can divide the exponent by 2, which is going to be 1. So I'm going to have a 2x in each, and then the square root of 9 is going to be a 3. Here we go. Another one down. If we go to this one looks a little bit different. Our variables are different. We have 2 variables here, but that's okay. You're going to do the same rule. We have perfect squares. We have even exponents. We have 2 terms. We have subtraction. We're going to do dots. It's up to you guys to know when to use what factoring method. That's the real trick. Okay. I'm going to put my plus and my minus in the middle. And then again, all we're doing is taking the square root of both sides. Boom. So we know that the square root of 49 is going to be 7. So I'm going to put a 7 here, 7 here. We know whenever we're dealing with these exponents and variables, we're dividing it by 2. So we're just going to have a y to that invisible 1 power. So we have 7y, and then we're going to do the same thing to the other side. We have 81. Square root of 81 is going to be 9. So I'm going to put a 9 here and here. And then literally the same thing that we did with this y squared, or the same thing that we did with the x squareds. We know that it's going to be the same for here. So it's going to be z, z. Boom. That's our answer. Let's box it. I hope we're doing good so far. Okay, now we see something like this. We notice here that our power is not 2. We've only been seeing 2 so far. We've only been seeing an exponent of 2 for each of these, but now this one is a 6. Again, we're literally going to do the same exact thing. We have 2 terms, we have perfect squares, we have even exponents, and we have subtraction. There's no reason why we couldn't do dots for this one. So again, my parentheses, my plus and minus goes in the middle, and we should be drawing those square root signs on both sides. Let's do the red one first. We just did this. The square root of 81 is going to be 9. Let me just move this out. It's going to be a 9 on each side. And then here, this rule, anytime we have or taking the square root of a variable with an exponent, we're dividing the exponent by 2. So down here, 6 divided by 2 is going to get us to 3. So instead of just being a regular x like we have been doing, it's going to be x to the 3rd power, just like that. This one, we have the square root of 121, which is going to be 11. 11. And at this point, we should know that the square root of y squared is just going to get us a y. So this right here is our final answer. Looks good. Let's move on. We have this one now. So this one is a little different. We see that I still have my even exponent. I still have 2 terms. I have my subtraction, but I don't see any perfect squares. What do we do in a case like this? Now, if you remember from my last video, the GCF video, if you haven't seen that video yet, I'll leave a tab up here for you guys to click on that. But you should always check for GCF first. So here, if we're looking closely, we can see that 2 and 50 have a GCF. And it just so happens to be 2. So let me just write that on the side. GCF. Our GCF is 2. I can divide this term by 2, and I can divide 50 by 2. So here, if we remember from my last video, I'm going to put my GCF on the outside, and all I'm going to do is write my original in the parentheses and divide each term by 2. So I'm going to put a 2 here. I'm going to put a 2 here. So now I'll have 2x squared divided by 2 is just going to get us an x squared. I'm going to bring down my subtraction sign. And then if I do 50 divided by 2, I'm going to get 25. So now if I'm looking at this, I notice here that with this invisible one here, we have our perfect squares, we have two terms, we have even exponents, and we have subtraction. We're going to do dots for sure. I'm going to keep my GCF on the outside. I'm going to keep it on the outside. And then I'm going to open up two sets of parentheses because we're doing dots here. Two sets. I'm going to put my plus and my minus in each of my parentheses. And then just like we've been doing with the other ones, I'm going to put my square root symbol over each of these terms. Now, we should know this one. The square root of x squared is just going to be an x. And the square root of 25 is going to be 5. So this would be your final answer. And this is a good example of how you can combine those factoring methods so that you can factor completely. Okay? So this was, let me write this here. So this was GCF, and this was dots. So now with something like this, it's going to be very similar to what we just did. I don't see any perfect squares. Everything else seems to match. We have two terms, we have subtraction, even exponents. We just don't have these perfect squares. But let's see if I can take the GCF first and then see if those perfect squares come. So here, my GCF is going to be 2. And if I do the same thing that we did in our last problem, I'm going to write the original. And then I'm going to divide each term by our GCF. And that should get us 2 times 4x squared minus 9y squared. And would you look at that? We have our perfect squares coming out to play. So now I'm able to do dots, and I'm going to open up 2 sets of parentheses now. I'm putting my signs in the middle, plus, minus, and then I'm putting my square root symbol over each of my terms. So now here, the square root of 4x squared should be 4x. The square root of 9y squared should be 3y. And literally, I'm just writing the same thing on the other side. 4x, 3y. And boom. We are good to go. All right, my last one here. I'm going to do the same thing. I don't have to take the GCF because my perfect squares are already out. Even exponent, 2 terms, subtraction. I'm just going to open up 2 parentheses. Square root symbols are going to go around each one. Can't forget about my plus and minus. I'm going to take the square root of 64x to the 4th power, which is going to be 8x squared. 8x squared goes here too. And then we have a 1 that goes here and a 1 that goes here. And boom, here's our answer. I'm actually going to move this down. Here is our answer. So there we have it. We factored with dots. If you have any other questions with factoring with dots or factoring with GCF, please let me know in the comments below. I also left a link for the shared Google Drive if any of you want to use this worksheet. My email is helpmemr.gordon@gmail.com if you have any other questions that you don't want to leave in the comments below. But other than that, I hope to see you guys next time. Bye.